All right, well, welcome everyone. Thanks for coming. This is a St. Louis Angular lunch. We've been doing this now for quite a few years, but we've only just recently signed up on Meetup. And so if you're new, thanks for coming. My name is Paul Spears. I work with Oasis Digital, and we host this Meetup every month. And yeah, so again, we're new to Meetup, so tell all your friends, let them know. We've been doing this for a while now, but we would really appreciate it if you kind of get the word out there and point them to our Meetup link so you can see and have a chance to be a part of this community here. A lot of great stories come out of here and a lot of great collaborations, so I'll definitely get that word out. But today, we've got Kevin Phelps, and he's going to be talking about handling network errors in Angular. So thank you very much, and I'll turn it over to Kevin.
Hi, yeah, like Bill said, I am Paul. I don't actually remember his name because I wasn't listening. That's embarrassing. I'm Kevin. I work at Vintage Software. We run a website called estatesales.net, and today I'm going to talk about an actual experience with some trouble we had launching our first Angular part of our site. So we rewrote a large piece of our site from web forms to Angular. So web forms is a traditional web application framework, and Angular is single page application. So there's a fundamental difference with how network errors are handled in those two different types of web applications. So in a traditional web application, the browser makes a document request to the server, and then the server sends back some HTML and the browser shows that. So if the server has an error, you can render an error page, and then the browser just shows an error page, and you can have on there, hey, an error happened, you should call our customer support. Or if a network request happens, the browser is unable to connect to the server while making that document request, it can show its own connection loss screen. That's the dinosaur page in Chrome. But in a single page application, that doesn't happen. We don't make a document request round trip connection to the server every time the user clicks a link or submits a form or navigates to a new view. The JavaScript application itself is responsible for rendering the page. So when there's a network error, either a non-successful status code as a response to an XHR request, or you're making an XHR request and the browser cannot connect due to a network error, that error is just thrown, and you have to handle that. So our number one complaint after we launched it was our city page, the page that lists our sales, was the site was broken. People would go to the site. So 60% of our traffic is mobile, and connections are flaky, network requests failed, and our app wasn't handling those. So the user would just see a loading spinner. So as an example here, I have an image search app that if I type in a search term, I have no idea why the empty white box is showing up. But if I type in a search term, let me type in something that's actually a word. It shows a loading spinner, and it makes a request. Let me switch to XHR. So it makes this search request, and it shows the pictures. Well, if I go offline, which because I zoomed in, I don't know where that is. If I go, where is the offline button? It's all the way over here. So I'm going to check this offline checkbox. And if I make a request, if I make a new search, let me refresh, something weird's happening. Yeah, so that's the dinosaur page I just mentioned. But demos hate me. Okay, offline, and then I make a new search. You should see yeah, there it is. So it failed to search. This request failed, and now all you see is a loading spinner. And the page is actually broken now. If I go back online, and I try to make another search, say I want to search for kittens, it doesn't work. Because I have a observable that's returning my search results, but that request failed. You can see this HTTP error response was thrown. And the page now does not work, because once an observable emits an error, it's done. If you have an error thrown, you're not handling it, it stops running that part of the code. So if you don't do anything to handle this error and one request fails, your entire application can just break. And that's what was happening to us. And people were calling in overwhelming numbers. Our customers were saying our site was broken. And for a while, we couldn't figure out what was going wrong because it worked fine for us. Famous last words. Then we realized what happens whenever you're not connected to the internet on our page. It just breaks, just like this. So today I'm going to talk about how we went about fixing that and this demo what you should do instead of showing this loading spinner whenever you have a connection failure. So I'm going to switch to the code, and I hope this is big enough for everyone to see. So I have this search results observable, and that's where I'm listening to the search term text box, and I'm making searches. And there's two ways in ArcsJS that you can handle an error. You can use the catch error operator, and what that does is instead of you have a try catch block in kind of synchronous code, that's the same thing. It's a catch. Something was thrown, you need to catch it. And what that expects, it gives you the error and expects you to give an alternate observable to subscribe to. So that's useful if you have like a cache you can look in or some default value you can emit in response to an error. But that's not super useful here because all I can do is emit an empty search results, and then the page would say no results found, but that's not really what happened. So we want to we just want to react to an error happening in the stream. So you can use a tap operator. And tap takes all the same parameters that subscribe does, next, error, and complete. I don't care about next, so I'm just going to pass undefined, and then I can react to an error happening in the stream. And what I'm going to do here is I'm just going to set a property show error. So instead of showing that loading spinner, I want to show an error instead. So let's just tell the component to show an error. So show error equals true. And I got to create that property. I got to put a comma at the end of that line too, so it quits complaining at me. There we go. Let's go up to the top and put a proper show error property right here, anywhere. And start it out as false because we don't want to show the error at the beginning. And then we go to the HTML, and we need to wrap this content, the form search box and the results, if I can select the right thing, in an ngIf, in a container that says don't show this when there's an error, or only show this when there's not an error. Otherwise we're going to show an error. So it says not error, else error. So just wrap this whole thing in that ng container, and then put our error handle, so let's put an error message on this page as well. So that else error would refer to this template with this name error, and then it has a button that says try again that you can't see because it's too far left. So try again button, let's call this try again handler error method. So let's put that in the component too. So I'm just going to put it right here. And the search result, I need to make it not read-only because I'm reassigning it. Because of how I construct that results observable, it starts out with the initial search term, so I just need to recreate it with whatever's currently typed into the box. So let's save both of these files and see what happens to in the application. It compiled, so it likes me. So let's refresh this. And my page comes up, and it works. And I make a search, and that also worked. That red one you see is canceled because I typed and it's debounced, so it canceled when I added a new letter. So let's check this offline checkbox and make another search. So you see it failed, and immediately you see an error has occurred instead of that loading spinner. And I hit try again, it's still failing because I didn't uncheck this. So we go back online, and we try again. Page works. So we fixed it. But we can do a little bit more. Like I said, mobile connections are notorious for being unreliable. A request can fail because it's just a bad area, users on the go, or it's just unreliable. So can fail, but maybe we want to just try again. GET requests are supposed to be idempotent. So if your API, your GET requests are idempotent, you can just retry them, and it doesn't matter. So ArcsJS makes that really easy. There's two ways to do that that I know of in RxJS. There's the, let's go to the code and go down here. That is supposed to, that's just because I have a constructor after a method. So don't know why it's showing up red. I told it to be warnings. So in this switch map where we do this get request, we can go after that and just add a retry operator. So we can just do .pipe, not pi, retry. And what retry does is it's an operator, it takes a number of time to retry. And it'll mirror emission, so anything on next and next it'll mirror, and it'll mirror complete from the source. But if there's an error, it'll resubscribe to the source. So if that request fails, it'll just immediately retry. So let's say we want to retry 3 times, and I think I'm missing a parenthesis. Yeah, there we go. And save that, and we go back to the demo and reload it to pull in the new code. And then we go, let's go offline and search for something else. It failed once, and then it tried again 3 times, just immediately. And then the same thing with that try again. It works. But then there's another thing you can do. Retrying immediately might not be very beneficial because the network might not work immediately. You might need to add a delay in there, and that's what we did. So when an error happens, we just wait a couple seconds and then try again. So there's an operator, a different operator you can use instead of just the retry operator. It's called retry when, and it's a lot more flexible, but a little bit more confusing. So I'm just going to paste in the line of code, and then I'll explain it. So right here, I'm going to paste this in and import these things. So retry when you give it it gives you a stream of errors. So just like retry, on next and on complete, it just mirrors. But when there's an error, it'll send that error to this errors observable that it gives you. And when your notifier, that's what I'm returning back, this errors.pipe, when it emits, retry when will resubscribe to the source. It'll redo that get request. So when your notifier emits, it'll retry. And when your notifier throws, it'll throw. So what I did here is I'm just switch mapping off the errors, and I'm taking the index. The switch map will also give you the index. For the first 3 errors, I'm just going to pipe through a delay 2000, so wait 2 seconds. And then after 3 times, I'm going to give up and just throw. So I'm going to, let's save that. And what that will do is when you reload and you go offline to simulate a bad connection and I search for something else, it failed, but it's waiting, and it's going to retry 2 seconds and then 2 seconds. But say I'm on a unreliable connection and I go back online before it gives up, I never see an error message. The user it's just a little bit slower. So the user doesn't have to click try again, and it's resilient against that unreliable connection that's spotty, where it fails and then you try again and it works. You just wait a little bit. So that we pushed that out, and it reduced the number of calls to our customer support a lot. And this works. But we went a little bit further. We have a search component, and this app is pretty simple. It just has one page, one component that does API requests and shows interaction with the user. But in a more complicated application, you might have dozens of pages that make multiple API requests, and you would have to put this retry when after every single one of them, and that would be tedious and error prone. EstateSales.net is a pretty complicated application, and in order to do this kind of approach on it, we needed a better way. So what we came up with is moving this retry when into an interceptor. So in Angular, it provides a concept called an HTTP interceptor. So anytime a request is made on the HTTP client service, it passes that request through a chain of interceptors, and those interceptors can modify the request. They can do something after the request. They can completely skip making the request and return something else. They're very powerful and very useful, and they apply to every request made in the application using the HTTP client. So we're going to just go ahead and we're just going to add a file called Retry Interceptor. And I'm going to just paste that in and then explain it, because I don't want to try to type it out right now. So it's just an injectable class let me get rid of this out of the way. It's an injectable class that implements HTTP interceptor. And that just means you implement an intercept method. And so anytime a request is made, Angular is going to call this intercept method, pass it the request, and the next handler in the pipe. That's either the next interceptor or the HTTP framework itself, the actual XHR request. So you can call, so the pattern is you would do something and call next.handle and do something else. So what I'm doing is I just have this variable called handle request. I'm just saying next handler, handle this request. But if the request is a GET request, I want to pipe it through this retry win. And that's the exact same line I had in my search component. I just put it here. So I don't have to put it after every GET call on HTTP client. I just put it here, and I provide, so it's a provider. It provides on the HTTP interceptors token, and it's a multi-provider. So let's go to our app components, and not app component, I meant app module, and put that in our providers list. And import it, and save, and then you can close that because I don't need that right now. I removed the line from the search component, so it doesn't have retry win here anymore. But if I go to my application, it works exactly the same. But it would work, it would do that retry with a delay on any request. So if I had multiple HTTP gets in my application, this would now apply to all of them. So just going to wait and retry. And so we pulled that out. We still have a little bit of tedious work, or tedious code in our search component. So the goal here, to backtrack and explain again, is to not have to repeat all of this code in every component of our site. Well, we still have this error page, this error message in our search component. If we had multiple components, we would have to have this snippet of code everywhere. And if we wanted to update the wording of this error message, we would have to update it in every HTML component of our application, and that could be dozens of places. We want to put this in one place, so we can just have it in one place, update it in one place. So we're just going to take and cut that and put it in our app component, because this is the component that's always active on the application. So we can just put it there. And then we need to find some way to show this when an error happens, and a network error happens anywhere on our site. So what we can do for that is I'm going to paste in another service here. Let's create a new file. And I'm going to call it the network status service. And what this is, it's just basically a behavior subject. So we have a show network error behavior subject, and then a method that says show it or not show it. This is just here so we can communicate between two different parts of our site if an error has happened or not. You could use your NGRX store or whatever state management solution you use for this. I'm just using behavior subject because that's really easy to just put in here. So this could be dispatch action on your store, and this could be select a certain property out of your store if you're using NGRX. So in our interceptor, We don't want to move that. We want to, let's add a constructor and inject that network status service here. Actually, since this is a lot of typing, I'm actually just going to check out a branch and then show the pieces. Okay, so that is deleted from disk. Don't save it. So I just checked out a branch to pull in the code. This Retry Interceptor, I just injected the network status service here, and then after that retry when retry when actually ends up throwing it and giving up, we're going to have the same tap that we had in our search component that had show error equals true. We're just going to say set show network error to true. And then in our app component, actually from here, our search component, we've completely removed any error handling code. In our get search results, we don't have that. Show error, we don't have a show error property, and we don't have a show error template. We moved that here in the app component file. And on the router outlet, I moved that ngIf not show error else error to my router outlet. This was actually a really neat discovery whenever I was developing this, that you can actually ngIf the router outlet. Totally didn't expect this to actually work, but it does. So when that ngIf is false, it destroys the entire component tree for your routed component. And when it becomes true, it reinstantiates it. So the show network error is just that subject from that show network from that network status service. So when the retry interceptor ultimately stops retrying and says show network error true, it emits true on here, so the router outlet gets destroyed, and this network error gets shown, and then we have this try again, which all it does is basically the same thing as we did in the search component. We said show network error false. Instead of show error equals false, it's just emitting false on that observable. So then if we look at the application, this is all just a refactor. It's just moving the code out of the search component, out of the individual component, into the core of your application, inside of a service, and inside your app component. So if I go offline, just to show that it does work, let's just let it completely fail. It completely removed the search component, it destroyed it, and it showed that error message on the app component. And then if I go online and hit try again, it recreates the search component, and then it starts working again. So same way as we did in the search component, where we destroyed the form and the search results list, we just destroy the whole component and recreate it from the app component. But this means we don't have to have this tedious network error handling code everywhere on our site. We just put it in one place and it just works. So more things that you can do. So that's just what let me find my code again. On this retry interceptor, we're just saying if there's an error, we're going to try again. But you do have access to the actual HTTP error response here. You could put more complicated logic here. You could say if it's a connection error, which it'll say status equals 0 if it failed to connect. You could say, we want to retry network errors, but if the server actually responded with an unsuccessful status code, you can do different things. For example, if your server responded with a 500, you might not want to keep retrying that, because that might just make the problem with your server worse. If you're just, all your users are constantly retrying their 500 request, that would be kind of maybe a DDoS attack on yourself. So you can actually put logic in here to do different things in your retry when notifier for different error messages. And for that, I actually wrote a library called HTTP retry. I'm going to check out a different branch here. I'm going to check out my master branch of my demo, which I'll share a link to this demo and my library. But this, let me just pull up my README of my library first. So to install it, it's at ngx utilities /http retry on npm, and you import HTTP retry module for in your root module, and what that does is it provides a generic interceptor in Angular that takes in retry strategies. So how it works is it attaches to the HTTP pipeline, and anytime there's a failure, it looks at the status code and it passes it to a retry provider that you give it. So you can give it a network error retry strategy that says, I want to handle if the status is 0. Oh, I'm so sorry. There we go. Can you read? Yeah. One more. This is one screen I forgot to test. So it has a property. It says I apply to status 0, and we want to retry those maximum of 3 times. And you can provide a delay function that says if it's retry 1, 2, or 3, how long do you want to wait before retrying? So what that code says is it says retry immediately the first time, then wait 3 seconds. And then on failure, that's where you can dispatch to your network status service or your Nginx store to show that message in your app component. And then you can provide different ones. Say you want to handle 502 and 503, that's server unavailable and bad gateway. We use IIS. So when IIS is recycling because we recycled it or changed the machine configure or pushed new code, for a few seconds it sends 502 and 503. We just want to retry that. The server's just not available yet. So we just say, if you see that, wait 3 seconds, try again. Up to 10 times. So what that looks like in the app component is we actually have 2 error messages now because we're handling 2 different things. We're handling when there's a connection lost and when there's a server error. So I just use ng switch case. So my network status service has 2 things on it, connection lost and server error. When connection lost, I say can it show which one. And when I reset, I just say false on both of them. So the app works the same. I just imported a library instead of having the code in my application. So this is a really easy way to just put a few pieces of code in the core of your application and then not have to worry about network errors as much, for at least for GET requests. This kind of strategy won't work for things that aren't idempotent like post. If your puts are idempotent, you could maybe use that for puts. Deletes are supposed to be idempotent as well, but we just do that. We just handle my library only worries about gets because that's the safest thing to just retry indiscriminately. That's all I've got.
Before we do questions, we apologize for the delay in the pizza. It is here. I don't know if you want to do questions really quick and then eat and chat, or you're welcome to go grab pizza too, but we apologize for the traffic delay. Sorry about that. Thank you for... Sure. I'm sure. Are we starving?
Also, well.
All right. Well, in that case, yeah. I mean, if that's okay for the broadcast. Okay, yeah. So if you don't care, trickle in and get some food, and otherwise we can start Q&A in just a second.
And there are my links to my demo and the library, if you're interested. I'll grab it in a minute.
I've got
first, Kevin, thank you for an advanced talk. That is awesome. That's exactly what we are all about at Angular Lunch. So first, just thank you. I'm going to applaud you again if I could. I had a question. There was some like little attribute on some of your HTML elements. It was like 2 letters. I forget what 2. Does anybody notice a little 2-letter attribute?
Oh, BP.
What is that?
That is because
related to this, or is that totally unrelated?
that is because I work with Corey and I use his Blueprint CSS library.
Ah, okay. So that'll be another, like next month we can sign you up, or?
It's a Flexbox grid. It is on Corey's GitHub. So that's just how I showed the pictures in a grid. I was using that.
More questions?
So for me, kind of the hard part is not so much like how to handle the error as it is trying to like figure out what to do about it. How did you go about determining that, like, trying 3 times and putting up an error page was like the right thing to do?
We guessed. There's actually discussion going on our product team about what we should show instead of what we should actually show. But yeah, it was all I guess. The retrying 3 times, retrying 10 times, we guessed. So no science there.
So I work with Kevin, and there's an interesting thing that happens when you switch over to a single page app. Like a traditional server side, you get the dinosaur page when you go offline. So the users will tend to blame their internet service provider for the problem because they see the dinosaur. When you switch to a single page app and network issues happen, they blame your app now.
Yeah, they were calling and saying our app was broken.
Yes, because they see it's your app broken, so they call into us. So there's definitely a user perspective shift with the user. Yeah, so the moral of the story is make your error page look like Chrome's error offline page, and you're good.
I guess it would make sense then to make the service not only continue to retry the get, but also to possibly check some other site to see if the network is actually available. Yeah, because you have 2 different possibilities. One, they have no network connection
or
at
your
all,
server is down.
or your server is down.
Yes.
And so it'd be ideal
yeah.
to know which of those
that
cases
is
you're
an
dealing
interesting So when you get an HTTP error response that says status code 0, there are 2 possibilities. The user is unable to connect to your server because they have no network connection, or because your server is down. I could show my demo app, and instead of checking that offline checkbox, I could just stop my server, and it would behave exactly the same because it's the same. It doesn't know whether the server's up or you don't have a network connection. So the suggestion is to, when you see that, make a request to another site that you know is reliable to see if then you could determine my server's down or their network's down. That is something I had not thought of.
Yeah, but ultimately, the user doesn't care.
But you could
Ultimately, the user doesn't care.
And the user doesn't care, but you could show different messaging. Yeah. So you can say, instead of connection loss, my connection's fine. Instead of saying connection loss, you can say my server is having issues. You can show a different message in different cases then. Yes. The goal is to make the user blame the correct party.
So I think you said at the beginning that when you first switched to the single page app, you had like a lot of like customer complaints. It's not working.
Yes.
You put this in, it helped a lot.
Yes.
Like, can you give a sense of like how much is a lot? Like, I mean, do you still get some complaints, or did it just like totally go back to just as good as it was before you were doing a single page app?
No, I think so. We had like multiple layers of issues with when we first launched our Angular site. People saying that the site was broken because all I see is a loading spinner was a big part of it. We also had issues with like certain browsers were being weird with our service worker. So like we still have people call in. It's very low, I think now, saying that the site's not working. But it's usually someone who, a lot of times, like Firefox Focus on an iPhone will block things, and we serve our content over a CDN. And apparently it thinks Amazon CloudFront is a bad tracker, and I don't know why. But that has happened. So a lot of it now is just tracking down, like, why is your experience different than... Because they might have a weird filtering system on their computer, or different browsers do weird things. So just the normal web development problems.
I just had a comment. Kind of when the person asked about how many times should you retry and that sort of thing.
Yeah.
I think going back and disabling the search box, disabling the thing that you know is going to fail, is like the best plan. That seems really a smart way to do it. You went back and you took away the search box so they couldn't even generate network failure errors till it came back.
Okay.
Right? Like that seems like the best error strategy handling until it comes back.
Yeah, but if you went with something like that, then you go back to, and it's not necessarily a bad thing. My goal was, we have a complicated application with several pages and they each make multiple requests. I want to put an interceptor in and put just one place in our code to handle it. That might not be the best thing. You might want to do something different for each page, but then you go back to putting the error handling code on each individual page. That might be what's best for certain applications. And so, yeah. But you can't do something like that in the app component, because you have to do it in the individual components. So, yeah.
I have a general question really for the entire group. We're just getting started with Angular. Very, very new. We're curious what the level of development is being done with actual .NET, Visual Studio, building your APIs, and so forth through Visual Studio, and then building your Angular app. Are you doing the Angular app through Visual Studio or through VS Code?
I can just comment on my experience. We do have a .NET framework API, and we develop that in Visual Studio. But our Angular code, we use VS Code, Visual Studio Code. It's a lot more lightweight. I tend to have a worse experience working with Visual Studio than Visual Studio Code, because Visual Studio is just so heavy and it has so much stuff it's doing. But VS Code is a lot lighter. It's a text editor. You got good syntax highlighting, good language service support, and you got an integrated terminal. And that's all you really need for Angular development. Personally, I wouldn't recommend trying to develop an Angular app inside of full Visual Studio. I would use something like Visual Studio Code. There's also Atom Editor from GitHub, and there's like WebStorm. They're more lightweight.
I
don't know if that answers your question at all.
Yeah, no, it does. But because part of what we're looking at is, if you're going in, you're trying to debug your application. Do you don't have you don't know what's going on with your APIs.
Yeah.
If you're not running it through Visual Studio.
Yes. So yeah, whenever I'm debugging something and I know the API could be having issues, I'll run Visual Studio as well. But most of the time, I think most of our developers actually don't need to run the API in debug mode all the time. I very rarely need to do that. I can just run the VS Code with our Angular app in it, and it tends to work out pretty well. Just when I need to fire up Visual Studio, I do.
Does anybody else feel like chiming in on what to use? Or
we have an application that has a .NET API also as the back end and an Angular front end. And what we've done with the Angular build is we've set a build task such that it outputs directly into the wroot folder of the .NET project. So when you run the .NET project, it's also running the Angular project. And you can run the .NET project in debug mode if you're debugging the API, or you can run it in normal mode and your API is being hit, but it's not hitting the breakpoints. So it remains fast. And the only thing we've lost in that is the automatic refreshing of the browser when you hit save and it recompiles. But F5 in the in the browser, and it still reloads the recompiled Angular app. So you can have the best of both worlds. And you can integrate MVC Razor pages in there, have some routes actually hit MVC, and then have the rest of the Angular app actually hitting your Angular app.
Yeah. We accomplished something like that with a reverse proxy. So in our IS configuration, we have our main site. It's a proxy that if the URL matches a certain pattern, we send it to the server that's running the .NET app, or if it matches a different pattern, we send it to the Node server, because we run our server rendering a Node. So we just did that with a reverse proxy. Instead of copying our application into our .NET, they're separate, and we tie it up with a reverse proxy. So there's multiple different ways to do it.
We have a completely integrated environment with .NET and Angular, and breakpoints work beautifully. But I think it is slow, and it's like perfect but slow, to the point where I think most of us would rather have pulled the Angular app out.
Is that what ASP.NET Core, or is this
Core.
Yeah, so we've got a .NET back-end app and then an Angular front-end, and we've got our build process set up so you can run Visual Studio and launch up what we call the server side, and then it serves up the Angular app. But you can also fire up a simple Node server that just serves up those Angular app files, and with the browser link and the auto refresh and auto compile and those sorts of things. And the base URL that it hits can be configured. It doesn't have to be your local host anymore. So like I always fire up Visual Studio and fire up my own server and run it. Katie works with me, and she always points to this an instance we happen to have sitting up on a test server somewhere. And that instance is serving up our Angular app, but you don't have to go through the Angular app to get it. You're just setting this root URL in your development environment to point up into the internet. And then you don't have to worry about, is your database in the right place, and so on and so forth, as long as you're not developing on the server side stuff. That actually works pretty great.
That sounds amazing.
really?
Yeah.
So I have a vaguely related item. It's not exactly this, but it's close. So at the end of that very awesome conversation, I wanted to just get a show of hands. Raise your hand if you're doing any end-to-end protractor testing in any project at work. Counting 1, 2, 3, 4, 5, 6, 7. So 7 of which 4 work with me. So, okay, thank you all.